Next speaker is also a PhD, this time from MIT, Nathan Shnidman, will be telling us about some of these toasters that I was alluding to this morning. So these toasters that are taking over the world and why that's happening. Lexsumo is a very recent spin out of of MIT and of the Draper lab, which is a lab with very, very close connections to MIT, and Nathan can explain. They work on a lot of military applications. The world of machine learning and the world of IoT meshing together has created kind of unprecedented opportunities, especially combined with open source software, and this is what we'll be hearing about now. Nathan, thank you.
Thank you very much. Hi, I'm Nathan Shnidman. I'm here for one of the co-founders of Lexsumo. We're a cybersecurity company helping companies use open source software more safely. So before I get started, I just want to thank Trond and Quan and the ILP team for inviting us here and making this great venue, and BT for hosting. This is really an amazing space. So, who are Lexsumo? We started in Draper Laboratory. Draper was originally MIT's instrumentation laboratory and got spun off as a non-for-profit. Myself and the other two founders were directors working on a project called Big Code. It was a DARPA-funded project looking at big data for software. So, can you figure out the structure of software, the aspects of it, use big data type analytics and machine learning to do something interesting. And it was DARPA, right? So it's pie in the sky type stuff. So we started on that, realized we had some interesting technology, which I'll get into, and we could offer some services, starting off with full lifecycle management of open source security. And I'll get into what we mean by that in a little bit. At the moment, we're Cambridge-based, Cambridge, Mass-based, seed round. We have about 10 customers, and it says up there addressing IoT security. IoT, in this sense, is more embedded systems. So commercial IoT, your toasters, your TVs, your refrigerators, whatever else somebody decides to throw on the network. But also industrial controllers, medical devices, cars, and other transportation systems. We have a unique solution for C and C++ among other languages, which maps very well to those spaces. So open source is great. It has a ton of benefits. Everyone's using it, typically a lot more than they even realize. It lets you get the best of breed software quickly into your product right away. You get community experts making sure it's doing the right thing, auditing it. You don't have to hire somebody who knows everything about everything. And helps you get to where you need to be cheaper, faster. Unfortunately, there's a bunch of unforeseen costs or unexpected costs. Free isn't free. As soon as you incorporate that code into your software, you have concerns about how reliable is it, how safe is it. In general, open source software tends to be safer in that it's audited and people know what's going on. But as soon as you put that into your product chain, you need to keep up with what's going on with the rest of the world. You've now taken on all of the issues of that code. In addition, it's not just the code that you or your developers included, right? They use some open source packages for some good and specific reasons, but lots of times those packages have packages inside of them, and so on and so on. So lots of times people don't even realize the web of software that they've inherited and all of the vulnerabilities associated with that. So why do you care? Well, in the final analysis, your product is your product. You're responsible, and your brand is associated with that product, and people don't necessarily appreciate that there was an OpenSSL vulnerability, and that's why someone could hack into your router. It's your router with your name on it, and that's what people remember. So what do we mean by full lifecycle management of open source security? So I'll get into the sort of secret sauce and the technology behind it, but we have a way to do automated vulnerability discovery and remediation. That's key. It's not just, hey, you have a problem, you might want to go take a look at this. It's, here's a problem, here are some specific ways to address it, apply the one that makes the most sense for your development cycle for how you're using that code. So we typically scan customer software. We have a SaaS platform. Figuring out what open source you use. Lots of times that's the open source that you know you have, the inherited open source that you may not know you have, the couple of libraries that some developer snuck in because they didn't want to write another database layer or something else, and give you a bill of materials of everything that impacts the product you're building. In addition, we identify which vulnerabilities affect your code. So once we know what you have, we know what vulnerabilities could associate with it, but we take it a step further. We look at your actual build process and figure out which components are you really using, right? You might be using, just because it's a favorite pinata, OpenSSL, but you might not be using all the capabilities of OpenSSL. The Heartbleed, which the last slide referred to, really was based on the heartbeat server function of OpenSSL. If you're using it as a client, you don't have to worry about that. So it's not every vulnerability that could apply to everything. It's really what's specifically in your code, which ones do you have to worry about for what you're doing. We provide remediation. How do you fix it? Do you want to upgrade to the latest version? Sometimes you do, sometimes you don't. APIs can change. Parts of the code could have been modified to customize it for your solution. We can provide patching information, things like that, to allow you to fix it in place without having to constantly chase down the latest. And we provide monitoring service. That's why we're a SaaS platform. It's not a single scan. If your code changes, we can see that. If you fix something, we can see that and stop telling you about the fact that you've got this vulnerability because we can see it's been fixed in the code. If there are new exposures, new vulnerabilities, we can keep up with the latest. So how does all this work? It's, what's the magic behind it? So we used an index search method. So what we've done is we found a way to sort of gather all the world's software within a twiddle factor, so all the world's open source software, gather all the metadata associated with it, and map out what that code does on a semantic level as well as a textual level. So it's not just the file match. We actually can do deep introspection on the code itself to figure out the functionality, the structure, and map out all of the different features of the world's open source code. We then go back and annotate with vulnerability information, which is a process unto itself. Vulnerabilities tend to get reported. They tend to get reported very, very poorly. It's not clear what they apply to, but we have this map now that lets us infer all of the places where there might be problems. We're source code independent, CPU architecture independent with this representation, and actually we have independence from light modification of the code, right? If you've modified a comment over here or a function over there, but the problem's really down here, we can still do our thing. So we now have this, mapping of all the world's software, and we use graph analytics and machine learning to find what I'm calling points of interest. So you can think of a vulnerability as a certain type of point of interest on a map, a mountain, a castle, something that someone might care about. There's information out there about what that looks like, so we can use that to do this index search to match these things up and say, this castle's in your code, you're going to want to do something about it, regardless of what might be around it. Is there a moat? Is there not a moat, to belabor the analogy? So we're starting off looking at vulnerabilities as those points of interest, but there are other points of interest we can move to later. Disclosed vulnerabilities are one set. What about undisclosed vulnerabilities? If a known vulnerability looks like a mountain, well, what happens if there's a mountain over here, even if no one said anything about it? What about code inefficiencies, code reuse, defects in the code. There are various aspects, once you've sort of mapped everything out, that you can start to pull out and identify and match against. So what are we looking for? We're currently offering primarily C and C+ scanning on Linux, which is typically the hardest. We have Java coming soon and a whole bunch of other languages to follow. In typical DARPA fashion, this started as a DARPA project. We did the hairiest, nastiest, DARPA impossible thing first, and now we sort of get to inherit all the easier stuff after it. We're looking for paid pilots, referenceable accounts, but thrilled to talk to anyone. So please feel free to stop by and chat. Thank you.